In this question, you're being asked to rank the acidity of the following compounds in order of the weakest to the strongest acid. So, again, if you know the pKa value of all of these, which I don't know the pKa values of all of these, I know this one's probably about 35. I can tell this one's going to be less than that, and I can tell this one's also going to be less than 35, but I have no idea what the actual numbers for these are. And that's the downside to memorizing pKas. But again, I don't want you to do that anyways. If you're being asked to rank the acidity of molecules, I want you to compare the stability of the conjugate bases. Because remember, the stronger the acid is, the more stable its conjugate base is going to be. So what I would rather you do is draw the conjugate base of each of these. So the first thing we need to know is which protons are going to get ripped off, the ones on the nitrogens, or one of these ones on the carbon of the ring, or in this case, the carbon over here or the carbon of the ring. We have to figure out which ones are going to get ripped off. Well, the hydrogens on nitrogen are going to be more acidic because nitrogen is more electronegative than carbon, so it handles the negative charge better. So without drawing all the possible negative charge on carbon and comparing them to nitrogen, we're going to skip that. We know the hydrogens on the nitrogen are going to be more acidic because nitrogen is more electronegative. It'll handle that negative charge better. So let's pull a proton off of each of these. So starting with the one on the left, I'm going to take a hydrogen off of there. And I'm going to put those electrons. It already had a lone pair there. That's why I'm drawing in two. And in fact, I'll draw in all of these. All right. All right, so there's the conjugate base of the first one. Let's draw the conjugate base of the next one. Pulling off a proton, putting those electrons on. Okay. Let's draw the conjugate base of the next one. Okay. Now, all we want to do is we want to compare these three conjugate bases, and we want to ask ourselves, which one of these is handling the negative charge the best? Because if it's handling the negative charge the best, that means it was the easiest to form, which means it came from the most acidic acid out of the three. All right, well, let's just look at them. Each one has negative charge on nitrogen in each case. All right, so there's no difference there. There's no electronegativity difference there. But in some of them, the electron density is being delocalized via resonance. So these two here can engage in resonance. And what that means is they're going to be stabilizing the negative charge a lot more, which is going to make them weaker bases, which means they came from stronger acids. Right? This one here, that negative charge is just localized on that nitrogen atom. So that one is going to be the strongest base, which means it came from the weakest acid. So now that lets us know that this acid up here must be the weakest acid because it makes the strongest conjugate base, the least stable conjugate base. All right, so that's the weakest acid on the left. Now, out of these two, which one's handling the negative charge better? They both engage in resonance. These electrons can move here and kick that up there to form, I'll draw this in, to form this resonance structure. So we can see that negative charge is delocalized. Okay, this one here on the far right, it also does that. These electrons can move here and push that negative charge up there to form this resonance structure. Okay. All right. But that's not all it can form. So they don't have the same amount of resonance because the electrons can also move back and these can move over here, which pushes the charge up here, forming another resonance structure. So you can see that this structure here has the most delocalization of that electron density, which means this one on the far right is handling the negative charge the best, which means this is the most stable conjugate base, and therefore it came from the strongest acid. So there we have it. By evaluating the conjugate base stability, we were able to figure out that the structure on the far right here must be the most acidic. It's the strongest acid. This must be the weakest acid. And this one is sort of in between because it has a conjugate base that has a stability in between the other two conjugate bases. So again, whenever you're being asked to rank the acidity of molecules, don't even look at the acids. Instead, look at the conjugate bases and then compare the stability of the negative charge in each of the conjugate bases.